All right, everyone. I am here with Luna Dong. Luna is a senior principal scientist with Amazon working on product knowledge graphs. Luna, welcome to the TWiML AI podcast.
Thank you. Nice to meet you, Sam.
It's great to meet you, and I'm looking forward to our chat. Let's get started by having you introduce yourself to our audience. Tell us a little bit about your background and how you came to work in machine learning.
Sure. Yeah. So I'm Luna, and I work for Amazon. And the question regarding how I came to machine learning, this is an interesting question. And that reminded me my advisor. When I was a PhD student at UW, I often heard him saying, I'm from the AI community, and I came to database from the back door. And now, as you can imagine, I got my PhD from the database field. And that's the field where I'm sort of active for a long time. And now I'm coming to machine learning from the back door as well. So my advisor and I, we sort of make a circle. Yeah. So a little bit more about how I came to machine learning. So my PhD topic is about data integration. Basically, how we can seamlessly collect data from many, many different data sources and integrate them together. And then starting from 2012, so that's the time Google launched Knowledge Graph. And starting from then, Knowledge Graph has been a very popular concept. And big companies, universities, they put a lot of efforts into it. And if you think about a knowledge graph, you put all of the data from different sources and put it into this knowledge graph. So since then, I have been working on knowledge graph for the past about 9 years for now. And when you build a knowledge graph, you really need technology from all different fields. This includes natural language processing. So you need to understand texts. This includes image processing. You also want to get knowledge from images. This includes data mining. You want to mine the data from the text, from the graphs, and also this includes certainly database. You want to integrate the data, you want to clean up the data, you want to have high quality data. And in a sense, to build a great knowledge graph, you need all of the technologies. And that's how I came to machine learning field, because machine learning is the core for all of these fields.
Interesting. When you described the work you were doing on your PhD, it made me think of this challenge that we've been chasing after for the past, 10, 20, maybe even more years. That I think of as like enterprise information integration. We're going to create either some layer on top of all of the data to make it more easily accessible, or some centralized thing that sits on top of all of the information within an organization. It's interesting to think of a knowledge graph as, playing that role for many organizations.
That's true.
Tell us a little, when you think of knowledge graphs, and in particular product knowledge graphs, what are all of the things that go into making a robust knowledge graph?
Sure. Yeah, this is a great question. So knowledge graph is basically trying to mimic how human beings look at the real world. Before we are able to read and write, we already understand the real world. And to the little kids, those are mom, daddy, doggy, my house, my home. That's another house which is next to my house. And before any sort of a language thing, there are all of these entities and the relationships between the entities. That's how human beings understand the real world. And the knowledge graph is trying to capture that. And so what is a good knowledge graph? It certainly describes all of the entities and the relationships. And then I would say there are 3 key features for a knowledge graph. The first feature is, because it is entities and the relationships, it's structured data. So it is not just large paragraphs of texts. It describes the entities, the properties of the entities, the relationships between the entities. So that's the first thing. It is structured. The second thing is it is really high quality data. That means it's very rich data. You ideally want to know everything about the world. And it is clean data. There is no mistake, and you can fully trust a knowledge graph as an authority. And also, it is canonicalized. So for me, as an example, my official name is Xindong, and people know me by Luna. That doesn't matter. That's the same person. And over years, how I look might differ slightly, but that doesn't matter. That's the same person. I moved from company to companies for my job. That doesn't matter. That's still the same person. In the knowledge graph, there will be one entity represent me, not 5 different entities. So it's canonicalized. So that's the second big feature for a knowledge graph. It is rich, clean, and canonicalized high quality data. And the third one is the data are connected. So you connect the data about business, about movies, about music, about universities, about products. You connect all of them into one single knowledge graph. And then you know, hey, this movie star and that song artist, that's actually the same person. You know, this T-shirt with Darth Vader, and that's a character from that movie, Star Wars. And everything is connected, so we can reason about it. So that's the third thing about knowledge graph. So these are all important features to build a great knowledge graph. And because this is kind of high criteria standard, that's also why we need to explore all different technologies such that we can build a great knowledge graph.
When you say high quality and clean data, I think of curated, and that often has the connotation of human curation. I imagine that this is one of the areas where you might want to apply machine learning to improve your ability to deliver a knowledge graph, at least at the scale of a product database, or even a smaller one like movies and other types of knowledge graphs.
Yeah, that's a great point. There are so many products, and also there are so many entities in the world, actually. So just using product domain as an example, we have billions of products, and every day we will have changes to millions of products. And if we want to manually curate everything, it's just impossible. And also, not to talk about individual products, let's have a guess how many different product types there are. It's not hundreds, it's not thousands. It is like close to millions, depending on what is the granularity we want to model. And with all of these many different product types, each type has its unique product properties and also so many different products. Curation is impossible. So that's why machine learning plays a critical role to scale up.
Is that curation element the only place where machine learning comes in constructing a knowledge graph, or are there other areas where you might want to use ML?
Yeah, that's a good question. So curation is one place where machine learning plays an important role. Another important role is now we have this huge knowledge graph. How we are going to put them into real applications. We want to help people to easily search for the knowledge. And that's where search, natural language processing, all of these machine learning techniques being critical. And certainly we want to answer questions using our knowledge graph. That's where it is important. And also we want to use the structured rich knowledge to do recommendations, to also explain why we make such recommendations. And that's another place where machine learning plays an important role.
Nice. So you talked a little bit about the high level challenges of knowledge base, particularly as it applies to products. Can we maybe take a step back and have you share a bit about Amazon's efforts to build out a product knowledge graph? How long has this been going on, and what are some of the major steps and milestones along the way?
Mhm.
Was the
Sure.
product in existence when you started at Amazon, or were you part of the team that helped create it?
I'm part of the team that initiated this effort. So I joined Amazon 4 years ago,
Okay.
4+ years, and that's the time we started this project. And the effort is covering multiple different. You can consider it as areas of applications. So Amazon is a huge company, and one kind of product knowledge graph we are building is a media knowledge graph. So everything you can consider about like books, music, movies, and possibly even like podcast. This is kind of a media products. And that's where we apply some kind of techniques to collect knowledge. And I will tell you what is unique about it. But before that, let me tell you another kind of products. That's retail products. And everything sort of you put in the electronics, furniture, so the clothes, and the what you put into your kitchen, your bathroom, those products, those are retail products, and that require a different set of techniques. And in addition to all of this, web is a huge source of data, of knowledge. And so one big pillar of this project is web knowledge extraction. And that's where we are able to sort of get external information. For example, the information provided by the brand websites. And so that's another part of this project. How can we collect data from the web and use that to support the product knowledge graph, as well as help Alexa?
Mm-hmm.
Yeah. So let me say a little bit more why I separate media products and retail products.
Okay.
And although they are all products, but the data behind them are very different. And for media, the publishers for the music, the movies, the books, they are very well trained and good at providing the meta information. So who is the director of this movie? Who is the singer of this song? When is this movie released? What is the language, etc., etc. And there are a lot of decent information from different sources. And our job is to integrate the data from those different sources, different publishers, and make them seamless. So recall that this is also related to where I was from. I'm from the data integration community, database community. For retail, it is different. The retailers, they are not well trained to generate all of this structured information. Instead, everything is in the product title, the product descriptions, and also a whole bunch of bullets. It's not structured information. So for the retail products, we have one extra step where we need to pull the structured information out of the text, out of the images. And also we need to remove all of the noises that are provided for various reasons. And so that's why retail product graph is giving us extra challenges.
Okay. You said what I was thinking, in that the information extraction, that's a rich domain of research and practice in and of itself. Extracting information from particularly unstructured sources like blocks of text and images.
Yes.
An area that we've been working at for a long time. Are there synergies when you're looking at the problem in conjunction with the knowledge graph problem, or do you take off-the-shelf extraction techniques and then apply them in a vacuum, and then you have some bundle of structured information that you then integrate into your knowledge graph?
Sure. So this is very nice question. And in a sense, I would say information extraction at the very beginning, that's possibly 30 years ago, it started with extracting two kinds of information. One is the is a relationship. So, for example, this person is an artist, things like that. And then another big set of information they're extracting is event information. So from the news articles, what are the events, who, where, when, what, how, etc., etc. And it's really at the time when knowledge graph is getting popular in industry, that's the time we see a boost for information extraction. So instead of that, in addition to that two kinds of set of information we extract, now people are interested in extracting relationships between the entities. So that's where people look at all of the articles, all of them. Also, something we call the semi-structured websites. For example, if you go to Rotten Tomato, you go to IMDb, you see the data is not big sort of text, but data in some format in the web pages. We call it semi-structured data. So people start extracting information from those kind of data sources and try to say, hey, this is the relationship between this movie and this person. And this is sort of this particular property of this product. So it is helping each other in terms of how the two fields are growing.
And so when you're taking on a new extraction project, are you also utilizing the existing knowledge graph to help you with the extraction, or are you extracting the information in a vacuum?
Cool. So we want to use as much existing knowledge as possible. So when we extract the knowledge, we need to train models. And the training data basically come from two sources. One source is certainly manual labels. It's very painful to manually label everything for different relationships from different sources, and also for different entity types. And so then naturally another big source is existing knowledge. So we call it seed knowledge, and we apply weak learning. We use the seed knowledge to automatically generate the training data that will help us to train the model. And that is the most scalable way, because really just manually collecting training data, this is very hard. And on the other hand, this is just like how human beings learn. The more you know, the faster you learn, and the more knowledgeable you will be.
And so when you're talking about kind of building a training data set for this extraction problem, at what level of the problem are we talking about applying machine learning? For example, you've talked about extracting entities from text. That's one that is, it's a well-known problem, the named entity extraction. Likewise, we've talked about extracting text from images. You also have, I've seen some work on trying to do extract structured data from web pages in a way that's more robust to those pages changing than the usual, XPath or, HTML parsing.
Yes.
Are you applying machine learning into all of these or to
Yes.
a subset of them?
Everything. Let me tell you the whole sort of workflow.
Okay.
So we start with knowledge extraction, where we extract knowledge from product descriptions from the web. And for the web, it includes both texts and the semi-structured data, and also something called web tables. Basically, you have tabular information, a table on your web page. And for products, we extract it from texts and from images. And so these are all like machine learning methods developed by NLP community, developed from the computer vision community. And after we extract all of the knowledge, we try to integrate them together. We try to decide, as I mentioned, this Luna Dong and that Xindong are the same person. We try to decide, is director of and the director are actually the same relationship, even though different websites, different data sources call it differently, but that's the same relationship. So for this integration, we also use machine learning, and this is techniques developed by the database community, data mining community, as well as the NLP community. And after that, we put everything together and we try to decide if something is wrong. So we decide if something is wrong by looking for inconsistencies. For example, if most of the colors are like red, blue, etc., and suddenly we see something like vanilla flavored, and we know, hey, this is not a color. So that's one kind of inconsistency. Another thing is we might look at the values from different products, sort of neighborhood products. For example, for ice cream, and their flavor will mainly be chocolate, coffee, mint, vanilla, and suddenly we see spicy, and if that's not from India, we will guess this is unlikely to be correct. And yes, and we also look at inconsistency from different data sources, and I'm always amazed how different data sources give us different information about even some like very popular, famous sort of movie stars and singers. And we need to decide, was she born on February 28th or March 28th? Which one is the correct one? So that's called data fusion. And all of this, again, is using techniques developed by the database community, the machine learning community for anomaly detection, for example, and also from the data mining community as well. How to identify the inconsistent information and claim something is wrong and remove it from the knowledge graph. And one more thing for that is we learn embeddings, the representations for every entity and a relationship. That also helps us identify mistakes. And in addition, the embeddings can help us in downstream applications for search, for recommendation, and also for question answering. So that is a field by data mining community, by recommendation community, by the search and NLP communities. So you find machine learning plays an important role for every single step in this pipeline. And I often joke with my colleagues, with my students. So our goal is to build the most authoritative and richest knowledge graph. And we would apply whatever technologies, we will adjust it, we will invent new technologies to achieve that goal. And if mechanical engineering is the way to help us build this knowledge graph, we will learn that. But actually, it turns out machine learning is really the key technique to do this. But it's not like one single technique, but it is machine learning technologies invented by many different fields.
Sure, sure. When you apply that last step where you're identifying anomalies or out of distribution data,
Mhm.
however you want to think of it, does that then percolate up to a human in the loop, or do you have automated resolution techniques for addressing that kind of information, that kind
Uh-huh.
of anomaly?
Yeah, human in the loop is always needed. And for the data business, human in the loop is important because we really want very high quality of the data. For machine learning techniques, if our goal is something like 90% precision, so basically when we make 10 predictions, 9 are correct. This is achievable still using machine learning, but when we want to get to 99%, without human in the loop, it's almost impossible. So the question here is really how to make a smart choice about where people will play a role and where machine will play a role. And so human beings can help in various ways. For example, they have to provide some manual annotations to help create the training data.
Mm-hmm.
Even if we sort of applied distance supervision, weak learning to collect the training data automatically, that data still originally oftentimes comes from human input. So in the product graph domain, a lot of data are come originally from the retailers. So that's one part. And later on, as we do the train the model, make the predictions, we need humans in the loop to tell us what is correct and what is incorrect. That's another big thing. And then in this process, from time to time, we need to check what is correct, what is concerning, and if there is any sort of domain knowledge that can definitely speed it up. And certainly at this moment, we are trying to apply AutoML as much as possible to reduce the human work.
Mm-hmm.
So talking about human in the loop, one place I got most inspired by human in the loop is in Amazon Fulfillment Center. And it is like a big sort of, it's like a park. And there is there is a central system that will sort of decide, okay, I need to count the number of items in this bin for products. I need to send this to those places so we can ship it out. We need to double check whether something seems to be wrong here. And it seems a central system knows everything about what it needs to achieve and does the best to sort of combine human powers and machine powers. And similarly for machine learning system, eventually it will be a seamless integration of human power and machine power so we can best leverage the intelligence, machine intelligence and human intelligence in a way that we can get the best knowledge.
Mm-hmm. You mentioned when you talked about the very front end of that process and pulling in the information from the web, is that targeted in the sense of you have some set of products and you have maybe a URL, a set of URLs where information about those products might exist and you're crawling those specifically? Or do you start with kind of a funnel applied to the big internet and identify pages that may be relevant broadly? How do you think about that funneling or that part of the process for a system at this scale?
Yeah, so this is a huge question to ask, actually, because eventually it is about how we balance the results and also the resources we need. So I can use product as a simple example, but the same idea may or may not apply to other domains. So for products, the brand websites, manufacturer websites, they provide a lot of information. And then it makes a lot of sense to figure out what are the different brands for the products, major brands especially, and then what are the websites for these manufacturers and brands, and then do targeted crawling. But one could imagine, let's say, if our goal is to collect all of the knowledge for music and for movies, if we only do targeted crawling, we might miss information for torso and especially long tail music and movies. So that's where targeted crawling may not be the best way.
Mm-hmm. And so it sounds like there's another part of the process where you're just crawling the entire web, and then you've got to relate it to the existing knowledge graph to see if a given page is even relevant to something that you care about.
Yeah, in a sense, yes. And that's also what Google does, because Google, in a sense, has access to the whole web. And it's a natural way to basically extract the knowledge from all of the websites.
Yeah,
eventually, it is a trade-off.
That suggests that that targeted versus not isn't really binary, right? You've got targeted in the sense of I've got URLs associated with a product, or then another level higher, I've got brands that are associated with a product. At a level higher, I could just Google this product and see what comes back and then crawl that. And then at the highest level, it's just crawl everything and then try to find relationships.
Yeah, it's definitely not binary. So there are a lot of different factors to consider. And also for different companies, it is also like a different sort of position. Taking Google as an example, it has access to the whole web. And that's a little different for Amazon.
You mentioned that you use embeddings. You create an embedding for and I'm not sure I'm being very precise here, either the product or the information that you get back, but at some point you're applying embeddings. And the example that came to mind was your earlier example about the ice cream flavors.
Yes.
And it prompted this idea of conditional embeddings. And is that a thing? Like, can you look at an embedding space and identify the distance of some set of flavors conditioned on ice cream?
True.
Is that a thing? What is that
exactly
called? Okay.
Yeah, that's very good insight. So basically, if we look at, spicy is a valid flavor, but we look at the products where spicy is a flavor, and we look at the type of those products, it's unlikely to be ice cream. And so when we learn the embeddings, it will capture all of this subtle relationship in a nice way, but implicit way. So instead of saying, hey, ice cream should not have these 5 different flavors, the embedding will basically say, for the spicy flavor, it mainly applies to products of these types. And that will help us to identify mistakes, saying, oh, this is a spicy ice cream. Something seems to be wrong, or at least unusual.
Yeah, I'm trying to think of how you create an embedding space that does that. Usually you would think of, the embedding space as being characterized by chocolate, vanilla, strawberry being clustered here, American ice cream, Indian ice cream being someplace distant, but those will all be similar. And how do you create a space so that Indian ice cream and spicy are close, and the regular ice cream or American ice cream and its flavors are close?
Yes, it is. I would say there are a lot of cool technologies in this, and there is a domain for knowledge graph embedding. And the idea behind it is actually simple but useful. So we can look at the entity, relationship entity as a triple. So it could be considered as subject, predicate, object, or subject, verb, object. And then when we put all of these triples together, and then look at all of the triples related to the spicy flavor, that's how we sort of learn the embedding from those triples.
Okay.
And note that this this embedding actually propagate. So when we look at all of the products that are related to this spicy flavor, the products itself already carry the information about their product types. So that's already encoded into their embedding. And then all of these things are propagated into this spicy flavor.
What's an example of a triple in this analogy that we're talking about with ice cream?
Yeah, so it is some product has flavor, spicy.
Mm-hmm.
Yeah.
Okay. Interesting. Yeah. The more of a graph type of a metaphor seems more intuitive for the kinds of relationships you're talking about relative to embedding.
Yeah.
But it's interesting all the different things that you can do with embeddings, including this.
Yes. Yeah. So recently, I would say in the past 5 years, this graph neural network has been getting a lot of attention and a lot of research, a lot of progress. And that's one of the most effective techniques for knowledge graph, because knowledge graph is a graph. And then using all of this graph neural net, you will be able to learn embedding for every node in the graph and then propagate the information.
And so the graphs that you're building, are these, is this a research topic? Do these power the Amazon.com that we go to today? Is it one knowledge graph for all of products, or is it some aggregation or ensemble even beneath the product level? Like how are these actualized within the Amazon business today?
Sure. So it is certainly there are a lot of research and the science investment going on that enables these techniques, but it's actually a production system. And we generate this structured knowledge for a lot of products, and we use that to support, I would say, 3 major kinds of applications. The one is search. So as a simple example, if you search for shampoo, and then you might say, okay, I want those products for male. And then we have this search navigation, and you could click a button to say, I'm more interested in shampoos for male. And so that's for search. It also helps us to understand the customer intent very well from the queries, and then try to match it to the ASINs. So that's the first type. The second type is recommendations. And using the knowledge, we can hopefully tell you, for example, this is a product you are viewing, and here are all of the other products that are mostly similar, but have maybe slightly different things, like the model is different, the memory is different, and there are more accessories, so on and so forth. So recommendation is the second thing. Both search and recommendation is a way to help people discover products. And the next thing is more of a displaying information about the products. So now for many products at Amazon, when you look at the detail page, you can see the structured information about particular properties of the products. And that is this kind of structured knowledge. And also you can see like comparison tables, and we are experimenting how we can generate better comparisons using the structured knowledge.
Great. Thinking about knowledge graphs and the kinds of things you're doing at large scale, how would you scale that down for someone who wanted to, start exploring this area and maybe do something at the personal level or the, much, much smaller business than Amazon level?
Yeah, that's a great question. So I think it's kind of providing the tooling and generic technologies. So before I work on the product domain, I didn't realize how different the product domain could be from the normal like Google Knowledge Graph, Bing Knowledge Graph.
Mm-hmm.
And so similarly, when people talk about like medical information, biology, I also see their unique challenges. And so if we will be able to sort of have a set of tools to help people to get knowledge for particular domains, that will help small businesses. And at this moment, the sort of the well-known knowledge graphs are mostly from big companies. One thing I think, I'm hoping we will be able to develop is those like services or tooling which will help small businesses to build their knowledge graphs. And in that domain, as I said, this generic techniques, that will be the key.
Mm-hmm. And are there things that come to mind? And when you describe a knowledge graph, a lot of what you think of in terms of relationships, you could start as simple as a relational database and, relate different products or entities, and you've got different attributes and things like that. But there's certainly a lot of other things you might want to do. Are you aware of, is that the kind of natural starting place, or are there knowledge graph tools, for someone that wants to build a graph, not necessarily subscribe to someone else's graph?
Mm-hmm, mm. So I think there are, I would say, 3 levels. The first level is how to provide the technology to store the knowledge graph.
Mm-hmm.
And as you said, relational database, it actually has exactly the same expressive power as graphs. In other words, anything that we can describe in a graph, we can store it in relational databases, and vice versa.
Mm-hmm.
And in addition, at AWS, there are all of these graph database tools as well. And so that's the first layer, how to store it. The
Mm-hmm.
second layer, I would say, is the tools to help people to really build their graph. For example, web extraction tools, or this linkage tools. When I have 2 different databases about movies, how do I know these 2 movies are the same movie? How do I know these 2 people are the same? And I see such sort of tools at different levels. So some of them are provided from AWS as well, but we need to sort of integrate them to be a big tool set that will cover all of the different techniques I mentioned in this knowledge graph pipeline.
Yeah.
And I would say there is actually a third level. I think at this moment, each company owns their own knowledge graph. And there is actually some common knowledge that belong to human beings. And that would be a good set to start with for building small, specialized knowledge graphs. If one day we could have those knowledge sort of as a service provided by different small business owners, small companies, that will be good as well.
Mm-hmm. Are you aware of any efforts to standardize, some kind of interface between knowledge graphs, federated knowledge graphs, so that, Amazons could hook into Googles, could hook into my little companies and
Mm-hmm.
give one API to a broader view of the world, or not?
Yeah, so I'm aware of such efforts from the research community.
Mhm.
I think there is one called Open Knowledge. So
Okay.
it is. I know a few people like from schema.org, and this is possibly even getting funding from the government
Mhm.
about trying to hook up different knowledge graphs.
Yeah.
I don't see that much of appetite among the companies. And I mean, I can definitely understand the reason behind it.
Sure.
It's huge efforts to build such a knowledge graph.
Sure. Sure. And the data is valuable, and they're not sure they want to share it just yet. A lot of
True.
effort goes into creating.
Exactly. Yeah. Data is valuable. And I mean, in a sense, we shouldn't get the data for free because otherwise people wouldn't have the motivation to work on data.
Mhm. Got it. Well, Luna, thanks so much for taking the time to share with us a bit about what you've been working on and talk about knowledge graphs. Very
Thank
cool.
you very much. I appreciate all of these insightful questions.
Thank you.